Okay, so back to Geography 110. Good to see all your smiling faces. All right, we will start today on Lecture 7, do Lecture 7 and 8 this week, finishing out the second block of the course on industry and retailing. And so today is very much taking off from the last lecture, which was about transportation and production systems, where you have systems that don't pack into one factory or in one cluster, but are spread out. And that is a big part of the modern industrial landscape, and so we have to understand how it works. So today I'm going to go beyond just transportation improvements, which is kind of old transportation geography. It was about, where the trains go and how fast and so on. And today it's very much about this thing called logistics. So today we're going to talk about first the problem of flow, and then the logistics revolution, and then talk about systems revolutions in the history of industrial development. It's kind of an interesting topic. So we'll start with the problem of flow, and our keys for today are that flow and stocks are part of production. They may be in the distribution sphere, or they may be in the production sphere, and we'll be kind of crossing between those and joining them up here to talk about the movement of goods and parts and supplies and final products through the system to get to market, to get produced, and to get to the point of sale. This is a highly spatial problem because, as we saw, production systems are divided not abstractly divisions of labor, but they are spatial divisions of labor. And you have to link this up. So it's a big spatial problem. And the management of that spatial problem, or the organization of it, however you want to put it, is absolutely crucial to the success and profitability of industry. Okay, and then the second key is that we're going through a logistics revolution, or have gone through one for the last 20 years. It goes beyond what I mentioned at the end of last lecture about containers, but it's much more a revolution in the management of entire systems and their flows. And indeed, it's global today, and pretty fantastic what they're able to do. Oh, I just thought of something. Okay, remind me, when I get to the end of the logistics revolution, that I need to talk about the fact that some of these supply chains are shortening today. And I was going to put a slide in on that, and I didn't. I'll cheat and stick it in for the PDFs, but remind me, somebody stick up their hand at that time. And then finally, there's such a thing as systems revolution. When we talk about things like Fordism or the Toyota system or Walmart today, we are talking about entire systems. And it goes way beyond simply adding more machines or more training or bigger corporations. There are a lot of things you hear that's being crucial to the ongoing industrial revolution, or just technology in the abstract, a better phone or a better machine. These kind of systems, organizational revolutions, have been absolutely crucial in the history of industry and of capitalism. Okay, can you see through that thing? The fan? No? Who said no? Get out of here. No, you can't. Well, I'll try to move the fan. No, it's okay. You'll still get sick. All right. But I'm going to stand over here and stay as far away from the noise as possible for the mic. Okay, so we'll start with the problem of flow. Okay, we have a number of categories here: flow and stock, tracking, quality control, production chains, demand pull. All variations on the theme. I love that picture. I pulled that off today. I love that picture of loaves of bread. You notice the spatial how compact the spatial organization of that production line is. Something you don't generally think of. But again, spatial organization, even at the micro scale within the factory, can be very, very important to efficiency. Okay, let's start with flow. Flow is simply the movement of material and product through the system, through stages of production, within a factory, between factories. This can also be true, by the way, between offices. We'll keep it simple. Well, if you're talking about medical records flowing to India to be processed and then back to Kaiser, as they do, that's a flow problem too. And then flowing to the point of sale, to retail. It's highly geographic, about linking up stages and places. It involves transport, of course, and communications that we talked about in the last lecture. And also physically, it involves movers within factories, which we didn't talk about. When we talk about transportation, we tend to think trucks. But within factories, you have little trucks called forklifts all over. Within factory complexes, they can be even bigger. Think of those trucks on an airport tarmac that are moving around delivering the food to the planes. Those are internal to this giant workplace called the airport. They're not external transport. So what do you call them? We don't really have a term for it. It's kind of flow movement within the workplace. And then there's the organization within the factory and between factories. There's a spatial organization as well that comes in here. And the Toyota system is very carefully spatially organized. Some other systems are not. Stock is a break in flows. But you do get breaks in flows. There's no such thing as continuous flow. That's an ideal. You can have continuous flow within segments of production, say in a refinery, but when the stuff comes out the end of the refinery, it's probably going to have to be stored. That's why Chevron has those big tanks on the hill next to their Richmond refinery, is to bring in oil or out. Sometimes, some of them I think are for final products that are waiting to be shipped. You just can't quite get it all to line up. So sometimes things pile up like here. I thought that was cute. But also, stocks maintain flows, because if I don't have product or materials ready, like these women in this production line, if they're packing, this looks like they're packing bread, but if the bread trays don't arrive so they can pack them, then there's a break in production. So you're having an extra bread tray here, rolls or whatever these are, looks like rolls, hamburger buns or whatever. Having an extra tray there is a stock that helps maintain the flow of work. So stocks are not always a problem. Stock is sometimes an absolute necessity to keep everything moving smoothly. It's also, stocks, of course, are very geographic. We talked about the problem of storage in Lecture 6 in the big sense of warehouses. This happens everywhere, though. Within factories, there are stock rooms. Within stores, there are stock rooms. Even big box stores are just stock giants warehouses where the stock is out in front of you. So stock and flow are very important to efficiency, to this basic problem in production, which is time. In production, distribution, it is time. I could have said time in production and distribution, probably should have. And to the capitalist, you want to minimize that time, because that time costs you. You want to maximize your flow in the minimum time. Keep the product moving. Keep it getting produced, keep it going to market, keep it selling, so on and so on and so on. Now, we're still in production here. So there is this ideal of continuous flow, which is the least time you could have, and you can get it with certain kind of chemical systems like refineries, but it's very hard to do it. The assembly line is a kind of an effort at continuous flow, although it's not actually continuous in the sense that it's modules, but it's close. It's an effort to try and get that. That's the logic of the assembly line, to try and make it continuous as possible. Labor time is involved here, like I just said. A little redundancy never hurts, although I don't want to be too repetitive here. That you need the materials at hand to work with, or else you waste labor time. You don't want workers standing around tapping their feet, going, where are the doorknobs? Where's the cloth? Where's the new thread? We could also talk about repair in that. That's an interesting question I don't really talk about here, but just a little side note, I don't have the slide, little side note, that modern factories have systems to detect wear and tear and breakdown in machinery, and get that machinery, first of all, maintain it as best as possible so it doesn't break down, but also where you get things like wear and tear in cutting tools or in sewing needles to replace them ahead of time and quickly, because if they break and it snarls up the cloth, which whenever you're sewing, you've got a bigger mess as anybody knows who's ever sewed, which is probably almost none of you, but used to be. Maybe some of you girls have sewed on sewing machines. Do girls still sew on sewing machines? Oh, okay, they're still sewing, my God. I thought there was an app for that now, you know. Okay, good. All right, we know that if a needle breaks or a thread breaks, it's a mess, so you want it. And often you'll replace, another thing about replacing a tool or a machine or repairing or fixing a machine before it breaks is that you start to get quality degradation. If the needle's wobbling, or if your cutting tool is starting to get a little dull, then the part isn't cut as perfectly as it should be. So that's another consideration. Okay, labor time. And then capital time is equally important here. That this is a very important part of revolutions in logistics, revolutions in stocking, trying to minimize stocks, because stocks are expensive. They're not free. They look free. Well, I produced it. It's sitting in the warehouse. It's sitting in the stockroom. They're sitting on the lot like these cars. And yet there's all kinds of money tied up in those cars. You've bought all the materials. You may have already paid the labor, but you haven't realized your revenues because you haven't sold it. So you want to minimize the time in stocks. And so there's been a big move in recent years, triggered by the Japanese, the Toyota revolution, which we'll come back to minimize stocks as much as possible. And again, you can't get rid of them entirely, because to minimize them completely would be to have no clothing on the racks down at the store, for example. That wouldn't make sense, would it? On the other hand, you don't want to have too much clothing on the racks, in too many sizes that isn't going to sell, or that doesn't allow you to display enough of a variety of products. So you leave some in the back room to have maximum variety on your showroom floor, for example. Okay, stocks, flows, and sales. Oh, here we go. I do have a slide on sales. Okay, getting product to market. You want to get it to where the demand is, what the demand is, and a big part of that is fashion shifts, changing consumer demand. Changes all the time in a lot of fields, like fashion clothes. Not so much in, plastic garbage bags. Pretty steady there. But you got to keep your stocks. You have to have stock on hand. You got to restock your shelves in retailing, but you don't want to overstock. You don't want to have, again, wasted extra stock just sitting around in your room or on the shelves. You'll constantly see supermarkets fiddling with this, tracking sales to realize that something, when you shop, you see this. There's certain items you see every time you go to the supermarket don't look like they've changed. But this brand of soup or this brand of macaroni just isn't moving. And then they'll take it off the shelf and they'll get rid of it, put up something that moves better. Keeping track of that, of course, is the trick. What is actually selling? What's moving? And that's where tracking comes in. Okay, so tracking is the process of keeping track of flows and stocks, knowing what you have out there, how much, where it is in the system. With flows, of course, it's watching stuff move through the system. Now, within a factory, you may think that's obvious, but it isn't always. But certainly, if you're shipping materials or parts from Taiwan to Chicago, you want to know where they are, and even more so if you're shipping to the customer. Well, even more so, I don't know, but shipping to customers, UPS and FedEx and so on, they'll track stuff so that if it hasn't shown up, you know where it is, and they know where it is, and they know what's gone wrong, who misplaced it, where it's misplaced, luggage at the airport, and I can go on and on. So. The goal of the tracking, of course, is what I just said, keep it flowing, keep your stock at the right level, so flows and stock management. Tracking systems are as old as can be. The old system of tracking was mostly keeping inventory. That is how much supply of materials do we have, how many doorknobs or car doors or rubber seals on the door do we have ready to go, and how fast is our line moving, how many are we going to need? Do we need 1 day stock, 2 day stock, a week stock? How many cars are coming out the other end sitting on the lot that haven't yet been taken off to the dealers? How many cars are sitting at the dealers' lot that aren't selling and aren't selling? How many have we sold this month? So you periodically keep accounts. So to track it, the fundamental thing is simply clipboards. Clipboards are still used for a lot of stuff, because they're a simple way of keeping track of what's going on. They can be used for flow, they can be used for stock, whatever. Today, of course, more and more things are digitized. They're put in computers where you have a stock of information. And then you've got to get that information to move around from place to place so it can be seen, so it can provide feedback on what's going on in your production system, how fast it's moving, how short your supplies are, and so on. And the ideal is that continuous. Now, there has been a revolution in the last, really goes back almost 40 years now, which is the barcode. Although there was this amusing moment, which is very old for you now, before you were born, where George Bush Sr., as president, went to the supermarket and didn't know what a barcode was, because rich people don't go to the supermarket. Somebody does it for them. But this is a long time thing, keeping inventories. One way to keep track of your sales is the humble old cash register. But National Cash Register became one of the biggest companies in America. It was an IT company in 1890. And they invented, I guess the cash register was invented in the 1880s maybe. A simple way to keep track of your money, and then as they got more complicated, they could keep track of totals of that sale, totals of sales during the day, put out little pieces of paper, and so on. And that was a way you could keep track of things. And they still at a lot of stores, you get that little piece of paper. That's for you, but often it's for them. I mean, think how primitive the credit card tracking system is in America compared to, say, the bank card system. The credit card system, you're still signing little pieces of paper. That's starting to go, you may have noticed. It's already gone in Europe. They haven't been signing pieces of paper for at least a decade. So barcodes come along about 40 years ago, and they're a miraculous way. You get these little readers, and you have all this information. You probably wonder, what's on a barcode? There you go, read that thing. Now you know what's on a barcode. So all the stuff about manufacturer, retailer, what kind of item it is, down to the fifth place, whatever. And today they're experimenting, of course, beyond barcodes. Now barcodes, are still fundamental. They put barcodes on containers. They put barcodes on cartons of stuff. They put barcodes on individual products. So they're all through the system. They're all being read and all going into the system and communicating this information about stocks and flows. Benetton and others, this is actually getting a little old. This is back to 03. Starting to put chips into the product or on the product. And as you know, some people put chips in their dogs, and some put them on their children. And we put them on prisoners and all kinds of things, ankle bracelets and so on. Technology leaks around, doesn't it? Okay, quality control. Got to stick this in here because it isn't enough to just move things fast, keep it cheap. You've always got this problem of the opposition between cheapness and quality. And in products, quality is really important, but also in the production process. And this became an obsession, again, with the Toyota system, taught the world, really, in the 1980s. which may seem a long time ago to you, but not to us old guys, that in the 1980s, the manufacturers were not paying enough attention to quality, and that it was costing them an enormous amount of money. It wasn't just that the Toyota didn't break down as much as the Ford, it didn't have many returns or repairs, didn't impact its reputation and its sales. I mean, the quality is Japanese cars weren't just cheaper, they held up better. And people started to find that out through things like Consumer Reports and other testing and just word of mouth, that these were holding up better. Well, why were they holding up better? And that really impacted sales. Why did they hold up better? Because the parts in them were better and were put together better. And their parts were better because Toyota was monitoring, and Honda and so on, were monitoring their parts as they came in the door to make sure that they were good quality. And then they were monitoring the places where parts were being fitted. Okay, you're going to put the door on the car. I seem to be obsessed with car doors. Or the axle. The guys at the workstation where they're putting the axles on realize that the axles aren't fitting into the spring housing right. There's something about they're trying to bolt it in there and the bolt isn't quite working right. They have to push on it, and that's not right. They immediately report that. And immediately bells go off, and the engineers from the process come down and look, and they immediately complain back to the supplier and say, your axles are off true, or they're a little too large. And it can be by microns, millimeters. Okay, so you need to get we're not taking these axles until you clean up your process. So that way you don't get defective axles in there. And of course that means you also don't have as many rejects at the end of the line when you do tests, and you take the car out for some test drives, and so on. Quality control, historically, was something that skilled workers did, and it's called craftsmanship. Stradivarius had very high quality control. But so did a lot of, you had to depend on your workers for quality control in any number, like steel casting plants or, woodworking plants. You had to depend on your jigsaw operator to cut the pieces right for Victorian houses. Well, that was, an imperfect process, but of course the whole system of developing skills in your workers was what was critical. Managers weren't measuring those parts until the 20th century at least. And it's only with the Fordism that they start measuring parts with calipers and so on. When you get standardized parts become universal. There's been a bit of that in the 19th century, but let's date it from the early 20th century. And it's really part of the Fordist revolution, was getting quality management, the managers and engineers paying attention to quality of pieces that are being done by workers and by machines, and having standards, having tests, whether it's calipers or it's eyeballing. And some of this testing is very crude. It's done by eyeballing. Say if you're in a tomato packing plant, it's still a lot of eyeballing of damaged or imperfect tomatoes coming along before you put them in the boxes. And of course, this is a test room here, and you get rejects and bins for rejects. And then of course you want to get feedback from the rejects. Why are they defective? Is the quality of the silicon going into the wafer not very good? Is the wafer not true? Are the cutting machines? Is the soldering not right? So on and so on. So in Fordism, or what was called Taylorism often, or Fordism, a lot of the management was going into time management and speed up. But with Toyota, it's just dramatically the quality management at every step of the way. So that's a major development. We'll come back to that. But it's a kind of quality. There has been a quality revolution. I didn't put that on the slide. But this attention to quality is really dramatic over the last 20 years or so, last generation. Okay, automated quality control, that's even better in some ways if you can get sensors to do it instead of eyeballing, instead of doing physical measurements or hand measurement. You have sensors that look at stuff, reject the tomato, reject the axle, or reject the screw housing, or whatever it is. This is a picture of some automatic testing system. And this can be within the factory or between factories. Cisco Systems monitors all its subcontractors of all the things it makes. And not only does the feedback go to the managers of those factories and those firms, it comes all the way back to Cisco's headquarters. So they're tracking everything all the time. As a very computerized, computer-savvy company, they've had this automated for quite a while. And again, it's a way of quality control and also production time control. Okay, what about quality? That brings us, the Cisco example, to this inter-factory kinds of control. How you manage multi-site production, whether it's within a firm or it's between firms. So you can do it in part, classically you did it through product specifications. You can do it through testing and rejection on delivery. Or what the Japanese started doing was much more oversight of their subcontractors and sending their engineers into the subcontractors' factories to oversee the processing to make sure that the axles or the bearings or whatever, the drive shaft or whatever it was being made to the highest standards that they demand. So that I call process specs. Then there's this question of timing and coordination over these large production systems. Now you can go, say you run out of paint to paint the cars in your car factory. You could theoretically run down to your local Kelly Moore paint store, but that probably isn't going to work. Probably won't be the right kind of paint. It's not enough paint. There's a lot of problems with buying paint on the spot market or just random purchases. Although it makes perfect sense if you're a house repair person in Berkeley, you're doing house restoration, you're going to repair somebody's floor, you need some varnish, you're going to go down to Ace Hardware and buy some varnish, and you probably have an account there. Okay. Now there's two kinds of this coordination that have become very noted in the literature, in economics and organization studies, management studies. One is called just in case, which is the old Fordist system, where you do have a contract to deliver engine housings, or deliver scrap metal to a steel mill furnace, or deliver coke to the steel furnace, or deliver fabric to the sewing room, and so on. But you buy in advance and you stock up. Now maybe the contract says, all right, deliver it once a week or once a month. It's usually, you're not going to stock up for the year, that would be stupid. So even in the old just-in-case system, they didn't infinitely stock. They did it, on a periodic basis, and made sense. Could you wake him up? Thank you. Ooh, I know it's hot. And that's often called Fordist. The idea is to keep the flow going by having buffer stocks. But the just-in-time system that came in with Toyota, the Toyota system, which is totally managed, you only order as you need it in very small amounts. Then you expect delivery from the supplier within a very short amount of time. And although I put it on a later slide, that means that you're going to put your suppliers near the assembly factory. You don't want them too far away, within 2 hours, so that they can get supplies to you quickly when you need them. Okay, you keep your stocks low, so the cost of stocking is low. It puts a lot of pressure on your contractors, but of course the point is, screw them.